हेलो डियर स्टूडेंट्स। जो आज का हमारा टॉपिक है, वी आर गोइंग टू सॉल्व वन मोर प्रॉब्लम ऑन दिस मेथड ऑफ इमेजेस, राइट? So this is one more problem on method of images, and in previous lecture we have already discussed one problem. So if we have two charts above that conducting plates, so how we can calculate the force on some charge, right? So we have calculated that. So today we are also going to discuss again that method of images. Now our problem is that this we have a ground, this metallic surface, metallic sphere of radius r. तो हमारे पास एक metallic sphere है जिसका radius capital R है, and it is surrounded by this concentric ring. So that means इनका center same है, तो इसके अराउंड एक रिंग है जिसका रेडियस है 5r from the center because it is concentric, right? So this ring, it carries some charge plus q. So that means इस रिंग पे हमारा क्या है, प्लस q चार्ज. Okay, and this charge is uniformly distributed. तो ये चार्ज इस पे uniformly distributed. So that means it is uniformly distributed. If at any point, if we calculate for some small element, we can calculate how much charge will be distributed over this. So that is equal to plus q, right? And this charge, what it will do? Because we have this metallic sphere, so this plus charge, it will induce some negative charge on the upper plate and positive charge will be on the lower side, right? तो इस पे नेगेटिव चार्ज आएगा, right? Okay, so there will be some negative charge on this and positive charge will be on the inner side of this conductive plate, and this we are going to ground it. तो उससे क्या होगा, जो हमारा पॉजिटिव चार्ज होगा, पॉजिटिव चार्ज ग्राउंड होगा, एंड जो नेट चार्ज हमारा होगा जिसको हम इंड्यूस्ड चार्ज कहते हैं, तो दैट विल बी नेगेटिव ऑन द अपर सरफेस ऑफ दैट कंडक्टिंग स्फीयर, राइट? एंड पॉजिटिव चार्ज गोज टू ग्राउंड. तो हमारे पास जो प्रॉब्लम है, सो वी हैव टू कैलकुलेट व्हाट विल बी द पोटेंशियल at point P, which is located at a distance of 5r from the center, right? Or you can calculate electric field also. First, let us calculate what will be the potential, because this problem says that we need to calculate that the electric potential at a point on the axis of the ring at a distance of 5r from the center. Okay. So again, with the help of this method of images, right? तो हम इसको क्या करेंगे? So instead of that, so we'll assume that we can have this is our ring, okay, और जिस पे पॉजिटिव चार्ज है, because this is as per our question, because charge q is uniformly distributed over this surface of this ring along its length, okay, and the radius of this concentric ring is, that is 5r. तो हमें क्या करना है, हमें कैलकुलेट करना है this electric potential at point P, so which is located at a distance of 5r. तो जो which is located at a distance of, sorry, this is 2r. So this is, sorry, this is 2r here. So because this is 2r here, so we can write here. So this will be 2r. Okay. Now तो हमें क्या कैलकुलेट करना है, हमें कैलकुलेट करना है कि कितना इलेक्ट्रिक पोटेंशियल एट पॉइंट पी होगा, एट पॉइंट पी पे होगा. तो वो हम कैसे कर सकते हैं? तो हमारे पास जो पोटेंशियल होगा एट पॉइंट पी, जो कितनी डिस्टेंस पे है, एट अ डिस्टेंस ऑफ 5r फ्रॉम द सेंटर, तो इसमें जो पोटेंशियल होगा, इट विल बी ड्यू टू दिस चार्ज, ड्यू टू द पॉजिटिव चार्ज ऑन द दिस रिंग, and the induced charge, negative charge on the this conducting sphere, right? तो इस प्रॉब्लम को हम इक्विवेलेंट लिखते हैं इसके बजाय, राइट? तो दैट मींस हमें चूज करना है. तो इन वन ऑफ माय लेक्चर, सो वी हैव डिस्कस्ड दैट हमने देखना है कि अगर हमारे पास एक कंडक्टिंग स्फीयर होगा तो उसको हम रिप्लेस कर सकते हैं with the help of some we choose some imaginary that surface over which is called equipotential surface, जिस पे पोटेंशियल कांस्टेंट होगा. तो दैट मीन्स मुझे देखना है कि किस डिस्टेंस पे मुझे चार्ज रखना है और कितना चार्ज रखना है, राइट. तो दैट मीन्स यहाँ पे मेरा जो चार्ज होगा तो उस इमेज चार्ज का मुझे देखना है कि ये दैट शुड लाई विद इन दिस कंसेंट्रिक रिंग. तो हमें कहाँ पे लेना है, तो पहले हमें देखना है कि कितना चार्ज लेना है. फॉर एग्जाम्पल अगर हमारे यहाँ पे सपोज देयर इज dq अमाउंट ऑफ चार्ज, right? Suppose this is, we have some dq amount of charge on this at this point on this concentric ring. तो हमें देखना है कि जो चार्ज यहाँ पे होगा, because image charge is basically that is negative of that, right? And it is you can say that mirror image which is located at equal distance, right? But below that conducting plane. तो जो conducting plane है, जो हमारा concentric ring है, तो इसके नीचे हमें रखना है, right? तो हमें पहले देखना है कि कितना image charge. So that means image charge हम लिखते हैं, जो इमेज चार्ज होगा कितना चार्ज होगा इमेज चार्ज. सो दैट विल बी इक्वल टू द रेडियस ऑफ दिस कंडक्टिंग स्फीयर, क्योंकि इसका रेडियस कितना है, जो हमारा कंडक्टिंग स्फीयर है इसका रेडियस r है. तो दैट मींस रेडियस ऑफ कंडक्टिंग स्फीयर दैट इज r डिवाइड बाय द रेडियस ऑफ कंसेंट्रिक रिंग. सो दैट इज इक्वल टू 2r, राइट. सो दैट मींस इट विल बी 2r इनटू जो चार्ज यहाँ पे होगा, कहाँ पे, एट on this concentric ring. So that will be this amount of charge I have to place somewhere within this concentric ring so that we can have this potential, some constant potential, right? Or you can say that so we can have this equipotential surface at that point. Okay. So that means so itna charge hमें लेना है. Suppose we have this q amount of charge. So this will be equal to some dq by q. dq by 2, right? और यहाँ पे मैं अगर चार्ज q लूंगा तो यहाँ पे आएगा देन इट विल बी माइनस q by 2. तो मुझे कितना चार्ज लेना है, तो मुझे लेना है यहाँ पे कितना, so the charge that I have to take, so the charge, so image charge will be equal to that will be equal to the radius of that conducting sphere divided by twice r, because 2r is that radius of that concentric ring, and suppose this is charge q here, so that will be equal to q by, right. So that means यहाँ पे जो हमारा ये कंडक्टिंग रिंग है, तो यहाँ पे हमें रखना है किसी पॉइंट पे इमेज चार्ज, कितना चार्ज रखना है, तो हमें रखना है माइनस q by 2, राइट. तो माइनस q by 2 अमाउंट ऑफ चार्ज रखना है. अब हमें देखना है कि किस डिस्टेंस पे रखना है, एट व्हाट डिस्टेंस वी हैव टू place this minus q by 2 charge so that we can have that equipotential surface at that point. तो हमें देखना है कि at what distance. तो distance क्या होगा, distance होगा, so we can write that what will be that image distance. So image distance will be, that will be equal to r square divided by the radius of that concentric ring. तो जो हमारा concentric ring है, इसका जो रेडियस है that is 2r, right? तो हमें लेना है r square by 2r. So we can write then, so this will be r square by 2r. So that is equal to r by 2. So that means जो हमारा चार्ज है यहाँ पे, I will again plot here. So this is our 5r and this is point P, which is located at a distance of 5r, and हमें इमेज चार्ज लेना है किस डिस्टेंस पे, r by 2. तो सपोज दिस इज, सॉरी दिस इज दैट 2r, ओके 2r. तो हमें लेना है किस डिस्टेंस पे हमें इमेज चार्ज रखना है, एट अ डिस्टेंस ऑफ r by 2. सपोज दिस इज r हियर, तो दिस विल बी r by 2. तो इस पॉइंट पे हमें चार्ज रखना है, और कितना, क्योंकि इस पे क्या है चार्ज, प्लस q चार्ज, ओके. तो इस पॉइंट पे हमें चार्ज कितना रखना है, माइनस q by 2. तो किस डिस्टेंस, क्योंकि हमें इमेज चार्ज जो रखना है दैट इज माइनस क्यू बाई टू, यहाँ इस पॉइंट पे रखना है, एंड विच विल बी एट अ डिस्टेंस ऑफ आर डिवाइड बाई, तो किस डिस्टेंस पे होना चाहिए, एट अ डिस्टेंस ऑफ आर बाई टू, राइट। तो आर बाई टू डिस्टेंस पे हमें वो इमेज चार्ज रखना है, so that they can have we can have this equipotential surface. So due to effect of these charges, we have this, the potential of this, it is constant throughout this region. So this region is our equipotential surface. ठीक है, तो इसके लिए आपको याद रखना है, तो पहले आपको याद रखना है कि इमेज चार्ज किस डिस्टेंस पे रखना है। तो इमेज चार्ज रखना है कि एक तो जो हमारा कंडक्टिंग स्फीयर होगा उसका रेडियस डिवाइड बाय दैट रेडियस ऑफ दैट कंसेंट्रिक रिंग, तो किस डिस्टेंस पे नहीं है, क्योंकि उसकी डिस्टेंस है 2r, एंड द टोटल चार्ज। अगर हम यहाँ पे चार्ज प्लस क्यों रखेंगे तो यहाँ पे हमें माइनस क्यों रखना है, बट हमें देखना है कि वो कितना रखना है, राइट। और इफ इट विल बी डी क्यू हियर, सो इट विल बी माइनस टाइम्स दैट, बिकॉज वी हैव प्लेस सम इमेज चार्ज, सो इट विल बी इमेज ऑफ दैट original charge, okay. So that means जो हमने यहाँ पे इमेज चार्ज रखा at a distance of r by 2, and that charge is minus q by 2, right. So this will act, तो ये it will work what that conductive sphere will do. So that means we can replace that problem. तो मैंने आपको I have already discussed that. So replacing that conductor by this image charge, right. So this will also give us the same result, right. So this is for convenience. So that is why we are using this method of charges, right. So I am replacing that conductor sphere by this image charges, and it produces the same kind of potential. So the problem becomes easy with the help of these image charges, right. Now it's okay. So we have calculated now. So this is clear. This distance, this is r by 2, and we know that how much charge we have to place. That is minus q by 2. So that means अगर यहाँ पे q होगा तो यहाँ पे हमें रखना है minus q by 2 at a distance of r by 2, right. Okay. So now we need to calculate. तो हमें calculate करना है कि how much potential will be at point P. So that potential will be due to these charges on the ring. तो जो यहाँ पे चार्ज है इस concentric ring पे which is uniformly distributed, और जो यहाँ पे इंड्यूस्ड चार्ज है, यहाँ पे आप जिसको हम इमेज चार्ज अब कहेंगे, तो द पोटेंशियल एट पॉइंट P will be due to the image charge and the charge on the concentric ring, right. So that means we can write the potential. So potential due to these charges plus q charge, so that will be equal to 1 over 4 pi epsilon naught q by r. So this r is this, okay. We can calculate now because our v will be equal to okay. So the potential due to plus q amount of charge will be, so that will be equal to you can write this as 1 by square root of 29 . तो ये पोटेंशियल किसकी वजह से है, जो हमारा चार्ज इस कंसेंट्रिक रिंग पे है which is uniformly distributed along its length, right. Now second potential will be due to the induced charge, और यहाँ पे हम कहेंगे image charge because I am replacing that conductor by this image charge, right. Second, the potential at point P will be due to the image charge which is placed at a distance of r by 2 from the center, right. So we can calculate now what will be our this v due to minus q by 2 of charge. Why I am writing minus q? Because हमें देखना है कि due to minus q by 2 of charge on this point. So that means I need to calculate this distance. So suppose this is r prime. Okay. So that will be equal to q upon 4 pi epsilon naught and this r prime will be equal to phi r square plus r by 2 ka whole square, right? So this is very clear. So I can write that this will be equal to 1 over okay, or can rewrite this as okay. So this will be the potential. तो ये जो potential हमारा है, this will be due to this minus q by 2 charge at point P, right? So the net potential will be sum of these two, right? So I can write this as, now the net potential will be V of plus q plus V of minus q by 2, right? So I can write this as, so our V net potential will be, that is V due to plus q charge minus plus potential due to minus q by 2 of, okay. Or you can write this as, so if you check that, so what's our this V of plus q? So V of plus q is 1 by square root of 29 q by epsilon naught r, right? So that is 1 by square root of 29. Okay. So this will be net potential. Or you can write this as, okay. So this will be our net potential. तो ये हमारा net potential होगा. तो अगर हमें अब देखना होगा what is the electric field at that point. तो electric field हम देख सकते हैं, because we can write that our electric field will be equal to, that is minus gradient of V, or this will be simply that minus partial by partial r, or sorry, this you can write it as partial by partial r, and or this will be equal to minus, and you can write this as, this will be okay. So this will be the electric field. तो इतना इलेक्ट्रिक फील्ड होगा कहाँ पे, एट पॉइंट P. We have calculated that potential, we can calculate the electric field. Now in addition to that, अगर instead of that, अगर हमारा spherical नहीं होगा, it can be elliptical or it can be of different shape. Like in previous this problem we have discussed that if we have that this infinite that conductive plane, right? So if any type of shape, अगर हमारे पास कोई type of shape भी होगा, so we can replace that conductive plane by those image charges, and we can, because as I already told, मैंने आपको already, क्योंकि distribution of charge वहाँ पे पता नहीं होगा, because when we discuss that this problem, because when it induces this charge, when this ring induces some charge, negative charge on this conducting ring, right? So ये इसके ऊपर है, right? You don't think that this is outside. So it is lying on its this. So this is lying on its surface, above its surface, because this is located at a distance of 2r. ये r पे है, right? So that means यहाँ पे जो मतलब इंड्यूस्ड चार्ज होगा, क्योंकि उसका डिस्ट्रीब्यूशन हमें पता नहीं है, बट इट इज डिस्ट्रीब्यूशन इज नोन. द डिस्ट्रीब्यूशन ऑफ चार्ज ऑन द कंसंट्रिक रिंग वो हमें पता है, बट वी डोंट नो हाउ दिस चार्ज इज डिस्ट्रीब्यूटेड ऑन दिस कंडक्टिंग स्फीयर. तो हमें पता नहीं कैसे चार्ज डिस्ट्रीब्यूट है, बिकॉज दैट मीन्स चार्ज इज नॉट यूनिफॉर्मली डिस्ट्रीब्यूटेड. सो इन दैट केस, so when the charge is not distributed, अगर charge uniformly distribute होगा, so we can directly apply that. If we have that Poisson equation, or you can use that Laplace equation, so we can calculate with the help of those equations, or even that Gauss's law, E dot ds equal to q by epsilon naught, right? Or Coulomb's law you can see. So हम कोई भी law use कर सकते हैं, but if our charge distribution is known, but it is not known, right? Thank you.